everyone, in this video we are diving into Google's Tensor Processing Units or TPUs, the specialized AI chips that power everything from massive language models to Google's cloud AI services. I'll explain how they work, why the new 2025 Trillium TPU is such a game changer, and what all this means for the future of artificial intelligence. So, what exactly is a TPU? Think of it like a GPU's cousin. Both are built for heavy math, but TPUs are designed specifically for the tensor operations behind deep learning, especially matrix multiplication. Google first developed them back in 2016 to work hand in hand with TensorFlow. A TPU is a custom AI accelerator chip built by Google. While CPUs and GPUs are more general purpose, TPUs are laser focused on AI. They enable faster training and inference for machine learning models while using less energy than CPUs or GPUs. That efficiency is why Google runs so much of its AI infrastructure on them today. Now, let's quickly compare CPUs, GPUs, and TPUs. CPUs, the classic chips in every computer, are super flexible but not optimized for neural networks. They process instructions one by one, which slows down big AI workloads. GPUs, on the other hand, use thousands of tiny cores to run huge computations in parallel, which makes them way better for deep learning. But remember, GPUs are still general purpose, so they are not perfectly optimized. TPUs, that's where things get interesting. Google designs them as matrix processors. They are built for one job, handling the massive multiply and accumulate operations that dominate neural networks. Instead of wasting cycles fetching instructions like CPUs and GPUs, TPUs keep math flowing nonstop. This makes them the fastest option when you are working with very large AI models. Let's break down how they work. At the heart of every TPU are matrix units or MXUs. Imagine them as little math factories cranking out billions of multiplications and additions every single cycle. But those MXUs need data, and that's where high bandwidth memory or HBM comes in. It feeds data directly into MXUs, keeping them at full speed. And here's the cool part: Google doesn't just put TPUs in one data center. They spread across tightly connected facilities in places like Iowa, Nebraska, and Ohio linked with super fast fiber. Together, they function like one giant brain. Inside Google, researchers don't even think about the hardware. The XLA software stack handles it for them. So, TPUs aren't just powerful, they are smart and scalable. So, what's really going on inside a TPU? Each chip is filled with thousands of multiply accumulators, the little engines that do the core math of AI. Instead of constantly pulling data from registers or memory like GPU, TPUs are wired directly for matrix math. That's why they can train massive models in days instead of months. For example, the TPU V2 had over 32,000 multiply and add units working together. Newer generations have pushed that number even higher, creating a system where huge neural networks can actually be trained at scale. But of course, all this power comes with challenges like cooling. If you look at this picture of Google TPU data center, you will see the massive water pipes and cooling towers sitting on top of the facility. In fact, the chillers for cooling can be physically larger than the data center itself. That's because these chips generate enormous heat, and Google had to engineer one of the world's most advanced cooling infrastructures to keep them running. Now, let's talk about evolution. Google launched the first TPU back in 2016, designed for machine learning in search. Since then, we've had TPU V2, V3, V4, and V5e, each generation faster, more efficient, and better at scaling. The newest generation, the Trillium TPU, also known as TPU V6e, was announced at Google I/O 2024, and it's a huge leap forward. It has 4.7 times more compute per chip than V5e, 2 times the memory bandwidth, 2 times the interchip speed, and 67% better energy efficiency. That means training models like Gemma 2 or Llama 2 is now up to 4 times faster, while inference tasks like stable diffusion run up to 3 times quicker. All that with less energy consumed per operation. So, how are TPUs actually used? First, large language model training. Google's Gemini and Palm models rely on TPUs to handle their billions of parameters. Without TPUs, training these would take months instead of weeks. Second, Google services. Every time you search, translate text, originate photos, or get YouTube recommendations, TPUs are working behind the scenes to make those responses faster and smarter. And third, Cloud AI. Google Cloud lets businesses and developers run TPU on demand, so even startups can run large AI workloads without buying expensive hardware. This makes cutting edge AI accessible to more people. When TPUs are combined into racks and pods, they become AI supercomputers. On Google Cloud, you can spin up a few TPUs for a project or scale up to pods with hundreds of chips. These clusters reach exaflop scale performance, capable of training the largest language models we've ever seen. This is what makes TPUs not just a chip, but a backbone of modern AI infrastructure. So, to wrap it up, the TPU is a custom built chip designed from the ground up for deep learning. Over the years, it has evolved into a powerful, efficient, and scalable platform that fuels everything from massive AI models to everyday Google services. And now, with the Trillium TPU, we are seeing the fastest, greenest, and the most capable TPU generation yet, making AI training and inference quicker, cheaper, and more sustainable. In short, TPUs are one of the key technologies pushing AI forwards into the future.